The last video on parabolas in standard form is going to cover problems in which you're asked to find, probably you'll be asked to find the x-intercepts, but I'm going to include x and y-intercepts just as a quick recap of what those things mean. Basically, any graph, if we're talking about x and y intercepts, we know that x-intercept refers to where the graph crosses the x-axis. Well, something we should remember is that if a point is on the x-axis, such as right here, the only way that's possible is if the y value is 0. So this, for instance, would be the 3, 0 coordinates. Same thing for y-intercept. If a point is on the y-axis, the only way that's possible is if the x value is 0. Oops, I wanted to write 0, not x. Okay. So this would be the ordered pair 0, 4. So we use that to our advantage. You're going to be given some parabola. I'm just going to make up one. Let's say we have x squared minus 3x plus 7. Okay. If it's possible to factor, we can quickly find the x-intercepts by setting the y value equal to 0. Remember, if you're looking for x-intercept, the only way that's possible is if the y is equal to 0. So I make the y equal to 0. And I solve. Now, a lot of times what will happen is the function can factor. X squared minus 3x plus 7. You can sit here and try that all day long. It does not factor. I did that on purpose so that you can see a way of doing this that will always work is the quadratic formula. The quadratic formula, the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. This will give us our x value. So a is the first coefficient, which is 1. B is a negative 3, because that's the second coefficient here. And C is positive 7. We plug into that quadratic formula. The opposite of B, the opposite of negative 3, is plus 3. So positive 3. That's what I did here. This stands for the opposite. If B is negative, it becomes positive. If it's positive, it becomes negative. Now we have to do two things. We have to add and we have to subtract. That's going to give us, in many instances, two distinct answers. Plus or minus the square root of b squared. Okay, well, b is negative 3, and if I square negative 3, that's positive 9. Minus 4ac. So minus 4 times a, well, a is positive 1, times c, which is positive 7. All of this gets divided by 2 times the a value of 1, which is just 2 times 1. We simplify. This becomes 9 minus 28. And I chose a bad example here. We have, actually this isn't a bad example. We have a negative underneath the square root. 9 minus 28 is negative 19. We can't do the square root of negative 19. So in other words, this graph has no x-intercepts. How is that possible? Well, it doesn't cross the x-axis. It's an upward opening parabola. We'll show you this. Minimize. Okay, so if we look at x squared minus 3x plus 7, and I graph it under a standard viewing window, you'll see it does not cross the x-axis. It's above it. And so that's what is going to appear when that happens. We're going to get a negative number underneath this square root, making an answer, or a real answer, not exist. Now that won't always happen. A lot of times we are going to get an answer that works. And so what we'll do here, let's do another problem. And I will do one that has a real solution, or at least one real solution. So let's say we're going to find the x-intercepts for an equation y equals, we'll do x squared, let's try plus 6x. How would this work? Let me make sure this works here. After that, and let's try putting out here minus 20. I believe this one will have some real solutions for us. So if we're going to find the x-intercepts of this, again, y is going to equal 0 for that to happen. So I'll set it equal to 0. Okay, this one does not factor either. So I have an a value of 1, b is 6, c is negative 20, and I substitute into the quadratic formula. The opposite of b, plus or minus the square root of b squared, that's 6 squared, okay, minus 4 times the a value, which is 1, times the c value, which is negative 20. Okay, this one will work. All divided by 2 times a, well, that's 2 times 1. Keep on simplifying here. We have negative 6 plus or minus 36. Now it's 4 times 1 times 20. Well, that's 80, but it's minus a negative 80, so it's going to become plus 80. Because we have a negative 4 times a positive 1 times a negative 20. Right? All divided by 2. So since we have a positive sum underneath the square root, so negative 6 plus or minus, since that's positive, we're going to get some answers here. 80 plus 30, 6 is what, 116? Okay. The square root of 116 is not an exact, that's not a perfect square, 116, so we're going to get some decimal values here. So let's just get the decimal version of that, that's fine. First thing I'm going to do is negative 6. I'll use the plus sign first. The square root of 116. Okay, and I have to take that answer and divide by 2. So one of my answers is x is going to equal 2 point, let's call it 2.39. We'll round it off. The other answer we are going to get by using the minus sign. So negative 6 minus the square root of 116. Take that answer and we're going to divide that by 2. And we're going to call this negative 8.39. Those are our x-intercepts. Now I can demonstrate this by looking at the original equation. Put this into y equals in the calculator. So we have x squared plus 6x minus 20. Let's graph this thing. See if the standard window is good enough. It is. Let's lower that a little bit. See if we can see the whole graph. Not yet. There we go. So the intercepts are the two places where this crosses the x-axis. You can see that there's 2 of them. To calculate these, we don't use minimum or maximum. We use 0 because it's on the 0 line. That's where the y value is 0. So let's do the one over here first. Left bound means I have to go left of that point. So I keep going left until I pass it, like that. Hit enter. Right bound, I hit the right arrow until I pass it. Enter, and then enter a 3rd time. That's our negative 8.39 right there. Okay, so I'll demonstrate the other one. calculate the other 0, we got to go all the way over by this one, no? Alright, so I stay to the left of it, I hit enter, I pass over to the right of it until I cross it, enter, and then one more time, this will give me my 2.39. So you can see that algebraically we have found where the graph crosses the x-axis. We call those the x-intercepts. There's a few different scenarios that are possible for this. You can get two different answers like we just did. That would be the case where the graph crosses below and comes back up, giving us two solutions. That's two x-intercepts. Sometimes we're going to get only one x-intercept, and that would be if the vertex is actually on the x-axis. And this has one x-intercept. And the first example I gave us here is the case where the graph physically does not reach the x-axis. It stays above it, and this is when it has no x-intercepts. Those three things are all possible, and you will see answers that have all three of those characteristics. Now, the last thing I want to mention is I didn't talk to you about the y-intercept. Well, the y-intercept is nice. The y-intercept, if you look at it on a graph, means that the x value has to equal 0. This was the ordered pair I gave you before. That's a y-intercept that has the ordered pair 0, 4. So if I look at my equation that I had here, let's say we're going to find the y-intercept of this. All I got to do is plug in a 0 for x. X squared plus 6x minus 20. If I put in a 0 for x, this is 0, that's 0, I'm just left with negative 20. So this graph should cross the y-axis at negative 20. So let me demonstrate that to you. That's this point down here, but this is not the method I want to use to show you, but this is where I'm looking, okay, right around down there. That's the y-intercept. So let's find this. We're going to use the second trace again. Now, what I use for this is I use the first one, value. When I do this, it's going to ask me what x value do you want. I want x to be 0, and it finds it and shows me that it's 0, negative 20. Another option you have is you can go to the table, and you can look for the 0x. You'll find it next to the y value of negative 20. So that's the mechanics on how to find x and y intercepts of a parabola. And I believe this is going to be our last video here on this topic. And the rest of it I think we'll be able to cover in class. So bring your questions. This is chapter 2, so obviously this isn't going to be taking place until probably Wednesday night. You'll be looking at these things, or Tuesday night. So bring your questions.